Greetings, I'm Manuel De Stefano and I'm presenting refactoring recommendations based on the optimization of Socio-Technical Congruence, a work made by me, Fabiano Pecorelli, Damiano Tamburri, Fabio Falomba and Andrea De Lucia. I'm your today's speaker and those are my contacts if you want to keep in touch with me. A program must be continually adapted or it becomes progressively less satisfactory. This tells us Lemma's first law on software evolution. Indeed, a software to keep evolving requires maintenance activities aimed to enhance its functionalities. But not all the maintenance activities are meant to reflect to external behavior. Some of them are meant to improve the design of existing code and, in general, the source code quality under various aspects, and those are called refactoring activities. Refactoring, however, is not a trivial activity. Thus, a great number of tools and techniques have been developed to support developers in their maintenance work. However, recent studies have shown that social aspects play a central role in quality issues. And in particular, sometimes developers are afraid to perform some refactoring operations not to incur in social problems. So, socio-technical congruence plays a key role in quality issues. And to this extent, we have developed an approach to exploit socio-technical congruence to propose refactoring activities. And our approach is divided into steps. In the first one, we have the repository mining and socio-technical graph construction. And the second one, we have the graph optimization and refactoring recommendation. In the first step, mining the software repository, we are able to construct three graphs. The dev graph, representing developers' communications, file graph, representing source code files coupling, structural coupling, and then we have the dev file graph that represents the collaboration among developers. These three graphs are merged into one single graph that is called the socio-technical graph. That is our exploitation of the socio-technical congruence. This ends the first step. In the second step, we have the genome construction using the adjacency matrix representation of the socio-technical graph. And then this genome is fed into a genetic algorithm to find a suboptimal solution that represent the best fitted graph structure among communication, collaboration, and source code dependencies. In particular, our genetic algorithm is meant to optimize the communication between developers, this representing the first objective, the collaboration among developers, that are represented by the second objective, minimizing the coupling between source code files, represented by the third objective, and then minimizing the alteration of the original graph, in order to prevent the genetic algorithm to turn upside down the original structure, as the refactoring recommendation need to be simple linear steps toward the solution. And that's pretty much it for this presentation as late-breaking ideas. For our future work, we plan to validate the socio-technical graph construction approach by exploiting a dataset of a already analyzed project. Then we plan to conduct an empirical study aiming at assessing the architecture quality improvement after applying the recommended refactoring operation. And finally, we plan to consider other social aspects, developers' knowledge or role, for example, to perform a better optimization and taking into account both social and structural history. Thanks for watching.